All right, so guys, we're going to start here talking about what science is, okay? And we know that it's a way for you to gain your information, gather your information about things that you see in the natural world. And that's what makes science different from other things, okay? Science is based not only on opinion, but it's based on things that are tested over and over and over again. Just like some of you guys in your vocab, you probably use an example of what science is, maybe like biology or physics or chemistry, and then you use a non-example, something like mathematics or history or something like that. Okay? When we have an opinion in science, it is well tested. How's an opinion stated in the natural world, like everyday life? If you have a theory, how does it? It's like an opinion, right? Yeah. Okay? It's like an opinion. All right, so the goal of science. Scientists want to investigate things. Okay, so they want to study things, look at it, analyze it. Okay, they want to understand, they want to explain, and they want to make predictions. Why is it important to make a prediction? Someone raise their hand, please. Why is it important to make a prediction? Yes.
Maybe you can find out something that, like if you make a prediction for something like in your project. Wait, it's not going where I thought it would go.
Okay.
You can kind of anticipate what's going to happen.
Okay, you can anticipate what's going to happen. Okay, your prediction allows you to anticipate what's going to happen. Okay. All right, scientists also think about the world. Okay, they make observations. Okay, they make inferences. And an inference is a conclusion that you can draw upon. Okay? Science is always moving, guys. Always moving, always advancing. The thing about science is that a scientist is never afraid to be wrong and never afraid to disprove their theory, because a lot of things have been learned from hypotheses being disproved. Okay? So scientists are not afraid, again, of making mistakes, because from those mistakes you can actually improve on things. Okay, and uncertainty, not knowing. Those are all important aspects of science. All right, so aspects of designing an experiment include, first, we either have a problem or something that we want to look at. So we're going to state the problem. Okay? In stating the problem, then we have background information. Again, these things are all based off of your observation, a problem that you see, something that you might see that has to be adjusted or changed. Then we form a hypothesis. Okay? After we form our hypothesis, we're going to set up our controlled experiment, which includes our aspects of our experiment, our control, our variables, etc. From then, we will document our results. After documenting our results, we're going to analyze those results. And then we draw a conclusion and we publish our results. Why is it important to publish our results? Yes. Yeah.
So other scientists can try this experiment out?
Right. Well, why is it important for other scientists to try the experiments out?
To make sure you're correct.
Oh, sorry.
Okay, make sure you're correct. What else?
To test it to further prove your point.
Right, to test it. And that's what makes science different from other things, right? Because scientists can test other things. That's why it's not just an opinion. Okay, it's not just an opinion. All right, guys, so again, our problem is kind of the same as having an observation about something. There's something that we question. Okay, so when you have a problem, it's not like you're having a problem with one of your family members or something like that. Although you can kind of use this format sometimes to solve problems in our everyday lives. But the problem that we see is a question, more of a question that we have. All right? And so then we point to our background information. So what information do we have about that issue? Okay, so that's what that background information is. Then we create a hypothesis. And oftentimes, even when I was studying biology in high school, it's a scientific guess or an educated guess, but it's more than just a guess. Okay, it's more than a guess because we know that it is based off of research, data, scientific, factual stuff. So it's not just a guess like we just guess on something. It is a scientific guess, but you got to be careful with that word guess because that doesn't suggest that it's solid information, right? If you're guessing on something, you're not really sure about it. But in science, that's not necessarily the case because they've tested it, okay? And then people have agreed upon it. So then we test our results or test our hypothesis using the scientific method, okay, which we're going to go in full depth, and I'm sure you guys have gone over it before, using our variables, our independent variable, dependent variable, using our control, our data. Okay, we look at our data, we analyze that data as it says there, and then we make a conclusion. We accept or reject our hypothesis. A lot of our current discoveries have been found because the fact that people did this, rejected a hypothesis. Okay, there are a lot of discoveries that we have right now that were not intended. Penicillin, one of those things. Okay, not intended. People were studying something, but they didn't intend necessarily for that to be, what it was. Okay, but a lot of good things sometimes can happen from what may have been, a rejected hypothesis. All right, understanding these variables are very important, guys, because it determines how our experimentation is going to go. So the one that the experimenter changes actually has a hand in, adjusting or something like that. The one that you would change would be your manipulated variable. It's also called the independent variable. The one that changes as a result of what the scientist did, say that you are the scientist, is the dependent variable. So the dependent variable adjusts and changes based on what we do in our experimentation. Okay? Then we have our control group. Why is our control group important? Why is our control group important? Yes.
That's what controls the experiment.
Well, that's your standard of comparison. So you want to see a change happening, you gotta look at something that doesn't change in your experiment, something that's standard, something that is consistent throughout, so that you know what changes. Yes.
So would it be like if you had like two washing machines?
Okay.
White clothes in, and you put like a red sock in, one of them to see what would happen?
Okay.
Like that?
Well, the washing machine type might be the control. How much water adjusted, that sort of thing. Maybe the detergent being the same. Okay. So then you put that red sock in one of them, then yes, maybe you can. So the red sock itself would be a variable, okay, because that's changing in your experiment. Okay. So all the things that must be the same. All right, so when you're doing an experiment, you're comparing the study of music versus the study of non-music, and you have a group of students, the same number of students, feeding those same students the same meal, doing the studies at the same time every day, doing 5 to 10 different studies, etc. Okay? So this is basically just some practice information. A product called Skin So Soft is a mosquito repellent, but it isn't advertised as one. So what could your question be? If Skin So Soft is effective, or you're questioning whether or not it is. So the thing that we're wondering is this product an effective mosquito spray? All right? So what the background research does is that background research, the stuff that we know, helps us in our experimentation. Okay, so what are we looking for? We're looking for studies that people claim that it works. We're also going to look at studies of people that claim that it didn't work. We're looking at reviews, like Yelp, right? So when you go to a restaurant, you might go to Yelp or you might go to Google reviews or something like that. Why? Because you want to see whether or not the product is good or the restaurant is good, correct? As a matter of fact, I do that quite often now because my wife has pretty much banned me from reserving a hotel for us because I tend to pick some shady spots in the hood sometimes, you know? And she's like, yo, you gotta do some better job of your selection. So I don't care. I mean, I'll chill wherever. But anyhow, doing those reviews and doing that documented cases of people looking at stuff. Okay, so you want to look at the ingredients. You want to compare the odor and consistency. So that's all part of background knowledge. So possible hypotheses. Okay, remember if then. Okay, our hypothesis is an if-then statement. So, if skin so soft repels mosquitoes, all right, then we want to pick a specific result. Then there will be less mosquitoes on the side of the chamber where it has been sprayed. Then the person wearing it will have less bites after 30 minutes. So you see how you have your if statement, then you have your then statement that comes right after. Okay, and if we were making a prediction, what would we have? A because. Okay, so if then statement is your hypothesis, your prediction will be your if then because statement. All right, so what will we do to see if skin so soft works? We have our independent or manipulated variable. So what I want you to do is you may come up with a different independent variable than someone else based on your experimental design, but you can only have one independent variable. All right? Then your hypothesis, okay, based off of your independent variable. So it depends on which experiment you selected. So if skin so soft repels mosquitoes, then what? Who said it? Then you get less mosquito bites, right? What else? What could be another? Yes?
Then there would be less mosquitoes on the side you sprayed.
Okay, then it would be less mosquitoes on the side you sprayed in, since that's what you said would be possibly one of your independent, your manipulated variables, right? What else? Yes? You would not have to buy another repellent because skin so soft repels the mosquitoes, okay? What type of data will we write down for our dependent variable or responding variable? Okay, you can have more than one of these. These can be quantitative, which is always going to be numbers, versus qualitative, which is descriptive, okay? So I want you guys to think about it right now, and then I'll give some people an opportunity to tell me what their dependent variable or your responding variable would be. Because remember, the dependent variable is going to respond based on what you did into your experimentation. The amount of bites you have. Okay, good. What else? Okay, those are two good ones. All right. How will we make sure any differences in the results are due to skin so soft and not some other factor? Well, we obviously will not let our subjects use another product, correct? We will make sure that we know that they have the skin so soft. So this will be our comparison. Let's say I put on skin so soft and go outside and no mosquitoes bite me. Does that mean that skin so soft worked? Why or why not? Yes.
No, because maybe they were just like the mosquitoes around.
Yeah, maybe the mosquitoes just don't like you, right? Yeah.
No, because you haven't done more than one experiment to make sure that it works.
Good. You've only done one trial, one test. That's not a valid experimentation, right? So, controlled variables. All the other things we want to be the same for all of our subjects. For example, maybe they should have no cologne on. Okay? No food in their pocket, right? No similar clothing. Okay? Huh?
Should be wearing the same.
Right, you should be, thank you. You should be wearing the same clothing. Okay? same time of day. I mean, same pace. There are all kinds of things, guys, that when you're doing an experiment, they have to, when you're doing a controlled experiment, you don't want any variables that you're not calculating for to come into play. Okay? Okay, so our data that we use, we can use a variety of different things. We can use graphs, microscopes, anything that's going to calculate basically amounts, weights, distances, that sort of thing. That's what we can use to collect our data. Okay, and again, we're going to go over just a basic introduction. So I'll review this metric system thing for you guys who need it mostly. But meters, seconds, grams, liters, those are all examples of basic units. It's based on powers of 10 or tens, and the scientific basic measurement. And although we used an English style of measurement here, the metric system is consistent throughout the rest of the world. All right. The last part, because we're not going to do the line, bar, pie aspect of it. But right now, where it says graphing or undergraphing, after you've done your practice problems, you want to fill in the blank for analyzing our data. Okay. So when we're analyzing our data, we're always going to make sure that we study our charts, our graphs, and provide explanations for them. We must have the right kind of graph, okay? We must know where the independent variable and dependent variable go on those graphs. Okay, so that's what it means where it says you put the correct items on the correct axis, y versus x axis. We must label our graph as well. Always important to label our graphs. Not only with numerically, but we also must label it with the proper writing as well.